Hello viewers, in this video tutorial, we are going to talk about everything you need to know about ellipse. So get ready your pen and jotting notes, as I can guarantee that by the end of this video, you will be able to walk away with the actual and exact knowledge that will help you to solve any problems involving ellipse. So let's begin with what you need to know. The first thing you need to be familiar with is the orientation of the ellipse. As you can clearly see on the board, at the left hand side we have an ellipse with an horizontal orientation, and on the right hand side we have an ellipse with a vertical orientation. For the ellipse at the left hand side, from the center of the ellipse, thus the center of this ellipse, keep in mind, is actually the same as the center of the Cartesian plane, which means the center is at 0, 0. Now this ellipse is actually positive a units to the right of the Cartesian plane. So that means from this point, from the origin to this point, is a unit away. At the same time, it is negative a unit to the left of the Cartesian plane. Similarly, it is positive b unit away all the way upward the Cartesian plane, and it is negative b away all the way downward the Cartesian plane. Thus, the coordinates of this point is therefore positive a, 0, and the coordinate of this point is thus negative a, 0. Same thing applies to the vertical part. The coordinate of this point is going to be b, 0, and for this one, that's going to be minus b, 0. Now, each of these coordinates is actually been considered, they are categorized under some categories. There's something called vertices. That's a plural name for the word vertex. Vertex is a point where two lines come to meet. Now, the ellipse is actually in red color, and the Cartesian plane is actually in black color. Now look at these points that are highlighted in blue. This point, this point, and this point. Now if you take a look at them properly, you will see that the Cartesian plane, its line, and the line of the ellipse actually meet at those points. Thus, they can be considered to be vertices or to be vertex, whichever the case may be. So therefore, the horizontal points or the horizontal vertex or vertices is then categorized as the major vertices of the ellipse. Okay, that is if the ellipse is actually an horizontal orientation ellipse, because usually the value of a is always more than b for all ellipse. So a is always greater than b for all ellipse. That's one thing you actually have to keep in mind. So the coordinate of the major vertices is simply positive a, 0 and negative a, 0. So some people might express it as, it's also implied that positive or minus a, 0. So whichever way you express it, you're actually on the safer side. Either you split it out or you have it compressed in the other way around. So that's the coordinate of the major vertices. Keep in mind, this is if you have this kind of ellipse. That is an ellipse that is horizontal in orientation and at the same time that is centered at the origin. By the time we consider some examples problem, you would be able to realize how we'll be applying this knowledge to these problems. Now, what about the coordinates of the minor vertices? For the minor vertices, this is related to the value of b, okay, that is considered as the vertical part. Thus, that is expressed as b, a, or 0, and minus b, 0. And just like before, we can also compress that to plus or minus b, 0. So that is the coordinates of the major vertices for the ellipse on the left hand side. Now, before we discuss some other properties of ellipse, let's also learn and get familiar with how to identify the coordinates of the major vertices and the minor vertices for the ellipse on the right hand side. So now, let's begin. This ellipse its orientation is vertical. And remember, we said the value of A is always greater than B. Thus, it is A units all the way upward the Cartesian plane, and it is negative A units all the way downward the Cartesian plane. So once it is vertical in orientation, then the value of A will be along the y-axis. And if it is horizontal in orientation, the value of A will be along the horizontal axis. So the value of B will therefore be horizontal for the ellipse we have at the right hand side. So this will be negative B unit away towards the negative x-axis, and this will be what? Positive B away towards the positive x-axis. Perfect. Now to identify its coordinates of the major vertices, we need the coordinates of all these points. The points highlighted in blue. Now, since the center of this ellipse is actually at the origin as well, 0, 0, thus its coordinates along the left hand side for the negative x-axis, that will be negative b, 0, and for this, that's going to be positive b, 0. Now, for the major vertices, that's going to be 0, a, and this would be 0, minus a. Now remember, the major vertices is actually in relation to the value of a, because it always consists of the largest coordinates point. Thus, the coordinate of the major vertices here is going to be 0, a and 0, minus a. Or if you want to probably compress it, you can have it at 0, plus or minus a. Excellent. Now for the minor vertices, that's given as minus b, 0, and b, 0. So whichever comes first, it doesn't mean the order does not mean in excess, because you can actually express this as plus or minus b, 0. So this is accepted. So that's how you can easily identify the coordinates of the major and minor vertices of your ellipse. So this can be one kind of ellipse that is centered at the origin. You can have ellipse that is not centered at the origin as well. We will also consider it in this video tutorial. Now that you know how to identify the coordinates of the vertices, the next thing you need to be familiar with is the equation of the ellipse. At the left hand side, the equation is simply x squared divided by a squared plus y squared divided by b squared equals to 1. And for the ellipse at the right hand side, the equation is expressed as x squared divided by b squared plus y squared divided by a squared, and that still equals to 1. Now look at the difference. For the one at the left hand side, as you can see, the value of a is under x. This clearly tells you that it's an ellipse that is horizontal in orientation. Remember, I said the value of a is always greater than b. Thus, it has a long or a high magnitude towards the x-axis. Thus, it will be elongated along the horizontal axis. Now look at this one, the one at the right hand side. The value of a is under y. This clearly means that it's an ellipse with a vertical orientation, which means it is very, very elongated along the y-axis. So this is how you can easily know what type of ellipse you are dealing with, by just saying its equation or its illustration. So now I've given you, we have 2 ways or 3 ways now that you can use to know what type of ellipse you're having. Either you can use the illustration by just saying it, or secondly, you can use the coordinates of the major vertices. Okay, if the coordinate of the major vertices is such that you are having value along a higher value along the x-axis, you can see x-axis is the one that is come first. Okay, it means you are having an ellipse that is horizontal in orientation. But if the value of a, or the largest value for the major vertices, is along the y-axis, as you can see, then it means you're having an ellipse with a vertical orientation. So that's one. You can use your vertices to identify what type of ellipse you're having. The second one is use the equation. If you want to use the equation, Look at the denominator under the coordinates given to you, or under the x-axis and y-axis given to you. The highest one, okay, you can see a squared is not greater than b. The highest one, that is whichever under which the highest one is, it tells you that ellipse, it has more magnitude along that axis. So since a squared is under x squared here, it means it's being elongated along the horizontal axis. And for this one, since a squared is under y squared, it means it is elongated along the y-axis. Am I communicating? Perfect. Now, the next thing we need to be familiar with is the center of the ellipse. Well, we actually don't need to discuss much of that, because as you already know that it's actually 0, 0. For the ellipse on the left hand side, the center is 0, 0. And for the one at the right hand side, the center is also 0, 0, because they are centered at the opposite. Now that you know how to identify the center, you must know how to identify foci. For the left ellipse at the left hand side, let me after in red. There's a distance between the center of the ellipse, or the center of the plane, and the major vertices of the ellipse. This is the distance, we call it C. So from the center of the Cartesian plane to a certain distance, we have C units away. So this ellipse is actually positive C units away from the center of the plane, and it's at the same time C units away from the negative C units away from the center of the Cartesian plane. Am I communicating? So now the foci is actually in relation to the value of C. So for the ellipse at the left hand side, the foci is simply plus or minus C, comma 0. Okay, because its coordinate along the y-axis is 0, but the C unit away along the positive x-axis and negative C unit away along the negative x-axis. Now, for this one, for the ellipse at the right hand side, it is C unit away towards the positive y-axis. Okay. So we call that point, we call it the foci. Foci is the plural for the word focus. So that's positive C, and it is negative C units away towards the negative y-axis. So we can call that negative C. So it's foci with those is 0, plus or minus C. Now please be paying attention. You can see the foci, the focus, is actually along the horizontal axis here, and that is why we are having its value to be in the x part. While for this one, is actually along the y part, it's actually along the vertical part, and that's why we are having its values in the y part. Am I communicating? So it's very, very important for you to know what type of ellipse you're actually dealing with. You understand? This will help you to be able to swift in answers in the appropriate position. You understand? It will help you to be able to substitute your answers in the appropriate position. Now that we have the coordinates of the foci, you must be familiar with something called the Latus Rectum. So the Latus Rectum, this is a straight line that is drawn from one end of the ellipse to the other opposite end of the ellipse. However, it has to pass through the focus. You can see it as a semicircle, as a diameter, yes, to say next. Diameter of a circle, what does it do? It actually passes through the center of the circle, and it's drawn from one end of the circle to the other end. But this one is not diameter because it doesn't split the ellipse into 2 halves. But its definition is actually very, very similar in sense to that of diameter. That's what I'm saying makes sense. So let me give you an illustration of it. Let me have it in blue. You can still see it in blue. So if a line is drawn from the end of this ellipse, it's still trying to say makes sense. And it passes through the end point of the focus, or the center of the focus, which is that point, and it touches the other end of the ellipse, then we call it a Latus Rectum. So written for short as LT or LR to say makes sense. Latus Rectum. Perfect. Now we also have it in another way. It's also here. Just bear with me. Oops, that's not straight enough. Okay, let's have it this way. Okay, again. So that's also Latus Rectum. LR. Perfect. So now what you actually need to be familiar with about this is how you can determine its magnitude. Okay. For the ellipse at the left-hand side, the length of the latus rectum. So LR, I'm writing on the top, okay? LR is equal to 2b squared over A. You understand? 2b squared over A. Just take the value of B, square it, and divide by A. So if you are finding it for this one, the value of A will be positive, and we are finding it for this one, the value of A will be negative. So if the latus rectum is negative, it shows that you are getting its value at the negative part. And if it's positive, it means you are getting its value at the positive part. So and the sign does not really make sense. You just need to pay attention to how to substitute the values appropriately. So that is the formula that can help you determine the length of the latus rectum. And if it is an ellipse with a vertical orientation, the latus rectum will be in this direction. This will be the first latus rectum, LT, and this will also be the second latus rectum, LT. Now the equation remains unchanged. It's still going to be 2b squared over A. So LT is equal to 2b squared over A. So this equation will help you to get the length or the magnitude of the latus rectum. So this is what you need to be familiar with about ellipse. That is, if the ellipse is actually centered at the origin. So we need to consider the other way around. It is an ellipse that is not centered at the origin. What actually is different between them? Okay, then after that, we will make our summary for you to actually be able to identify the distinguished. So now, or distinguish them. Let's consider ellipse that is not centered at the origin. So now on the board is two ellipses that are not centered at the origin. Now, these are the most common problems, especially when it comes to exam questions. At this point, you have to be very, very sensitive. Like I said, after this, we will now consider summary, so you can actually see the difference between them in just one view. For the ellipse on the left, the coordinate of its center now is not 0,0, as you can see. It's not at the center of the origin. Now at this point, we introduce new variables. We call the coordinate of the center, we call it h, k. So the coordinate of the center C would be h, k. Perfect. Now, its vertices still remain unchanged. Let me have it in blue. This is the first one along the horizontal axis. This is the second one along the horizontal axis. We call these two vertex or two vertices. They are plural, two vertices. We call them the major vertices. Okay. Now, the coordinates of the major vertices. If we talk about the equation, just calm down. The coordinate of the major vertices for this ellipse that is not centered at the origin would be the first one. Remember, we said from the center of the ellipse to this point, that is the vertex along the horizontal part, we have it to be what? To be positive A. And for the left-hand side, we have it to be negative A. I'm still paying attention to the ellipse at the left-hand side. Okay, I mentioned left-hand side, that is negative part along the for the ellipse. You understand the distance along the negative x-axis. Okay. Now we need this point. This point, its coordinate is not A, 0 anymore. The reason is because look at it now. It has some magnitude away from the center of the plane. You know, coordinate is actually in with respect to the plane. Okay. It has some magnitude away along the vertical part of the plane. So this magnitude is k, which corresponds to the center of the ellipse. Am I communicating? It corresponds to the center of the ellipse. Now it has even much more long distance along the horizontal part. So that is coming from here, coming to this point. So we need the magnitude of this distance. That will be its value along the horizontal axis. Now, don't forget, from here to here is A. Am I communicating? From here to here is A. Keep that in mind. Now, from here, let's say from here now to here, which is the center of the ellipse. What's that one? H. Thank you. Are we here? From here, which is from the center, from the center of the what's called of the plane itself to the center of the ellipse. That one is h. Now, from the center of the ellipse to the end point of the ellipse, that one is a. Thus, the coordinate of the major vertices for the right hand side will be brackets h plus a comma k. Am I communicating? Simple as that. I don't want this to be off, so I'm just going to flip everything back. I don't want this to go off. So I just use that to show you how we actually get h comma k. Okay, this can be left like minus a. So the coordinates, the first one will be h plus a comma k. Perfect. Now, what will be the second one? Let's see the second one now. And we need the second one. The second one is this point. This point. So we need the value of this point from the center of the plane along the x-axis, which is this distance. We need this distance. Actually, let me use red color. I want you to see it. So I need this distance like this. And I need this one too. This one is the one for y-axis. So what will be from year to year? From year to year, what would it be? How can we tell that? Let's look at it. Now remember, we said from year, let me cancel it now. From year to year, we said this value of h, because that's the center of the what? Of the ellipse. Okay. If from year to year is h, and from year, which is from year to year, is minus a. Tell me, if we add them together, what would happen? We will have this part left. Am I communicating? We will have that part left. Thus, we get its value along the x-axis. Why this one still remain k? Because it's actually the same thing as the magnitude of the value of k. Meanwhile, we can now set down the coordinates of the major vertices along the negative x-axis. For this ellipse that is not centered at the origin, is going to be h minus a. Let me be h minus a comma k. Am I communicating? Simple as that. Now, what about the minor vertices? This is just the part you need to actually get right. You understand? You feel me? I will give you the equation. Those ones are no problem, okay? But knowing how to properly, knowing how to properly, that's somehow. Okay, knowing how to properly place your coordinates is one of the best things you might actually want to know how to do when it comes to problems involving ellipse. Okay, so coordinate of the minor vertices now. Vertices. Okay, now let's identify that. Let that be clear. So we need this one. And I don't want it to be clear. Let it be let's use let's use blue. So this is this one and this one. So what will be the value of this along the x-axis? Along the x-axis, that's from year to year now. It's not so. From year to year. And from year to year, that's what? That's h. Thank you. That's h. So that's h, comma. So we need this value along the y-axis. Now, from year to year, we said this what? Is k. Excuse me. Thank you. Remember, we said from the center of the ellipse to the end point of the ellipse along the vertical part is positive b. If the ellipse is actually horizontal in nature. And from the center of the ellipse to the end point of the ellipse along the vertical part is negative b. Thank you. Now, to get from year to year, we can add from year to year, which is k, with from year to year, which is b. And that gives us k plus b. So we have k plus b. Thank you. Okay, so it means the first coordinate for the minor vertices will be h, comma k plus b. And even without wasting much of your time, if you know what the other one will be, can you guess? Perfect. I don't know if you guess that anyway, but I know some of you would actually get it right. So the second one will simply be h, comma k minus b. So let's figure it out. So we actually need these coordinates from year to year. still remain h. Nothing is touching that one. So that's how we got this h, okay, along the x-axis. Now we need from here to here alone. Are we there? From that place to that point alone. Remember, from here to here is k. However, from this point to this point is minus b. If we add them together, what would happen? They will cancel out and reduce it and give us from here to here. That's how we got k minus b. And that's it. Am I communicating? Perfect. Now, in a compressible form, the coordinates of the major vertices can be equals to h plus or minus a, comma k, and for the minor vertices can be equal to h, comma k, plus or minus b. So the choice is yours. So the major vertices and the minor vertices is cleared. For a ellipse that is horizontal in orientation and not centered at the origin. Now, before we talk about the equation, let's talk about major vertices and the minor vertices for ellipse at the right hand side. So the coordinate of the major vertices is this point, this one, and this one. Now its center is the h, k2. Okay, where h, this is bracket not c, where h is the distance along the x-axis and k is the distance along the y-axis. Are we communicating? Perfect. So we need this point. Oh, maybe. Remember, from the center of the ellipse all the way upward to the end point of the ellipse along the vertical path is positive a, and all the way downward is negative a. To the left is minus b, and to the right is positive b. Yeah. Now, from this point, let me now use, right. If I use yellow, can you see yellow in white? It's very, very rare. Okay, you can't really see it properly. But let me use red. From this point all the way to the center of the ellipse, we say that is k. Am I completing? That's k. Okay. Now, we need from this point all the way to this point. What do you think that would be? That would be this magnitude, this to this, which is k, plus from here to here, which is a. Are we completing? But remember, you can see it is actually vertically. So that will be the value along the vertical part. So if you want to write its coordinates along the x-axis remain unchanged. It's still k. Sorry, it's still h. So that will be h, comma k plus a. Thus, the major vertices for the ellipse that is vertical in orientation, the first one will be h, comma k plus a. Now for the second one, we need from here to here. So what would that be? Simple. That will be h, comma k minus a. Am I communicating? It's comma what? K minus a. Okay. Right now, let's do for the minor vertices. I don't really want to waste much time because by now it should have been getting different. So we have h, comma k minus a. Okay. Now let's focus on the minor now. This is the first minor. This is the second minor. Okay. Now, from here to here, we said it's b. Okay. From the end point to the center of the what's called of the ellipse, we said it's b. What we need from here to here. But from here to here is what? Is h. Thank you. That will be h plus b. Are we there? So that will be h plus b. So it means we are having h plus b, comma k. The k actually remain unchanged. From here to here is the k. So that will still be k. Okay. Now, for the second one, we need from this point to this point. That will just be from this point to this point minus from here to here. So that will just be h minus b. So that will be h minus b, comma k. K is still remain unchanged. So therefore, the minor vertices would be in bracket h plus b, comma k, and h minus b, comma k. So in a compressible form, you can have this one as h comma k plus or minus a, and you can have this one as h plus or minus b, comma k. So the choice is yours. So that is the major and the minor vertices for the two ellipses. Now let's talk about the formula, the equation. For the one at the left hand side, the equation is expressed as x minus h all squared divided by a squared plus y minus k all squared divided by b squared equals to 1. And for the one on the right hand side, that will be x minus h all squared. Now remember, we're having the longest magnitude along the y-axis, so that will be divided by b squared plus y minus k all squared divided by a squared equals to 1. So that is the equation of the two ellipses. Now that we know how to their equations, we can discuss about the coordinate of foci. Remember, the foci is with respect to C. However, C is a distance, some distance unit away from the center of the ellipse along the major axis, and it will be between the coordinate of the major vertices and the center of the ellipse. You get my point now? Let me come again. C is a distance between the center of the ellipse and the coordinate of the major vertices along the horizontal or along the major axis. So for this one, let's say this is C. It has to be some units away from the center of the ellipse, and this will be minus C. That will be minus C. Okay, perfect. Okay, so basically now we need the coordinate of this point with respect to the plane. Now, its coordinate, since it's actually along the x-axis or along the major axis, that will be h plus c, comma k, and the second one would be h minus c, comma k. So let me show you how I actually get that with its representation. So basically, the point highlighted in black, we actually need its coordinates. So we need its magnitude from this point to this point. We also need its magnitude from this point to this point. So let's get its magnitude along the horizontal part first. We need it from here to here. Remember, we said from here to here is the value of h. And we said from here to here is minus c. So adding them together, we would get from here to here. So that's how we got h minus c for this one, for that part. Now, the horizontal part still remains unchanged. The vertical part remains unchanged. It's still k. So that's why it's still k there. So that's how we got that. And same thing we apply to the positive part to get h plus c, comma k. But let me show you. Okay, do I don't need to show it here anymore because they're actually in line with each other. So now we need this point for the horizontal part, so for the vertical part, and for the horizontal part we need this line, the magnitude of this line. Okay, now from here to here, remember we said it's h, right? And from here to here, we said it's positive c. That's why we had h and c together. Okay, and for the k part, you can see it's still actually in line. That's still the same. Okay, so this is still the value of k. So that's why we have it as k like that. Now for the right hand side, the coordinate of the foci, f. Now instead of it to now be with respect to the value of h, which is along the x-axis, it will now be with respect to the value of k, which is along the vertical axis. So that will now be h comma k plus c and h comma k minus c. So it's simple as that. So that is the coordinate of the foci. Now the length of the Latus Rectum still remains unchanged. For this one, L R is still equal to 2b squared over a. And for this one, LR is still equal to 2b squared over a. Are we together? So that is that. Now we also need to talk about eccentricity. Okay, I almost forgot. We also have eccentricity. For an ellipse, the eccentricity is always less than 1. For an hyperbola, it's always greater than 1, while for parabola, it's equal to 1. Okay. there is an equation that helps us to get the ellipse. It actually remains unchanged for all forms of ellipse you're having. So it's basically expressed as lowercase e and is equal to the value of c divided by a. And with that being said, I also need to discuss about the formula that connects C, A, and B together. There's also a formula that connects C and B together in case that might be useful in any problem that it might be useful anytime. Okay, it's such that C squared is equal to A squared minus B squared. Okay, so we might not know where it might be useful in any particular problem. So just keep that in mind. Have this copy down as well. This might be useful. So that's the relationship between C, A, and B. And I can bet with you, this is what you actually need to be familiar with in order to succeed in solving problems on ellipses. The next thing you just need is how to find the equation of tangent and normal line to ellipse, and that will be another video entirely. But for now, this is enough for you to tackle any problems on ellipse. So now let's have a review. Let's have a summary of everything we have been discussing right from start. So I can actually get rid of this one right now, and we can have the summary. So basically, hold on, just get rid of this one. Alright. Then did I need to copy? I don't think so. Let me copy. So you can actually set the difference. Let have it in black. Okay. Everything will actually be in black. Okay, so if the ellipse is horizontal, and centered at origin, so this will be the corresponding values of its properties. So in the center C, let me write it in full, or let me just select that. C will be 0, 0. If it's horizontal, okay, the major vertices, I will write capital letter M, then V. Major vertices will be plus or minus A, 0. And minor vertices, I will write it as lowercase m, V. And that will be 0, plus or minus B. Am I communicating? Now, coordinates of the foci, F, that will be plus or minus C, 0. Latus rectum, LR, is still 2b squared over A. And lowercase e, eccentricity, is C over A. And the relationship between C and A and B is C squared equals A squared minus B squared. So that's it. So it's important for you to actually know the ellipse you are dealing with. So if it's horizontal in nature, this is how you are actually going to fit in all the values you are getting. Now, if it is vertical in orientation, vertical and centered at origin, the center will still be 0, 0. Now, major vertices, coordinates of major vertices. Now, instead of the value of A to be along the x-axis, remember that all coordinates are written on x, y. For vertical, the longest side, which is A, is not more along the x-axis, it's now along the y-axis. That's why the value of plus or minus A will now be in the y part. It will not be in the x part anymore. So that's actually what changes. You understand? You feel me? That's actually what changes. So that it now be 0, plus or minus A. You get now? Now for the minor vertices, it's just like opposites to themselves. Minor vertices will now be plus or minus B, 0. So I would plus or minus. Sorry. Because that minor vertices, the value of B now will now be along the x-axis. So plus or minus B, 0. Please know the difference exactly. Now, coordinate of the foci. Now, since C is actually relative, it's actually with respect to the value of A, is always along the major axis. And the major axis now is along the y-axis. Thus, C will not be in the x values anymore. It should now be a y value. You feel me now? Exactly. So that's how the foci 2 will now become 0, plus or minus C. Am I communicating? Exactly. Now, Latus rectum remain the same, 2b squared over A. Eccentricity remain the same, C over A. What else? C squared is equal to A squared minus B squared. Am I communicating? Perfect. And that's all. If the ellipse is centered origin. Now, horizontal orientation, not centered origin. I know that equation. Let me write equation. Almost forgot. So equation is x squared over A squared plus y squared over B squared equals to 1. This one is x squared over B squared plus y squared over a squared equals to 1. Excellent. Now, horizontal equation. Horizontal orientation and not centered. That's origin. And not centered at origin. Center now will be h comma k. Are we there? Will be h comma k. In fact, I can give you a hint. Just be familiar with this one. It's the first one. The next one, for the one that's not centered, the only thing we'll be changing is h and k. That's what. So instead of having zeros, we'll be having h and k because the center is no more 0, 0. So now for the major vertices now, capital letter MV will now be, now instead of it to be plus or minus a comma 0, take, this one is value of x, this one is value of y. Now plus or minus a you are having here is value of x, the 0 here is value of y. Just be adding the values of x together. Add value of x plural, add value of x together, add value of y's together, put it there. That's your answer. You feel me? Exactly. So that would be plus or minus a. You can say, okay, h plus or minus a. That makes sense. H plus or minus a, comma. Now 0 plus k, that's k. Perfect. Got that. Now lowercase mv. Instead of 0, 0 is now the value of x now. 0 plus h is h, comma. Then k plus or minus b. It's just like k plus or minus b. Excellent. You got that. That's cool. Am I communicating? Now, coordinate of foci. Coordinate of foci here is plus or minus c, comma 0. We need to add the value of h, comma k, which is the value of the center. So it's now be h plus or minus c, comma 0 plus k, that's k. Okay. Then the Latus Rectum remain the same, 2b squared over a. Eccentricity remain the same, c over a. And c squared is still equal to a squared minus b squared. Perfect. Gone. Equation x minus h all squared divided by a squared plus y minus k all squared divided by b squared equals to 1. Perfect. Now vertical orientation. Vertical and not centered. That's origin. Am I getting? Perfect. Then now the center is still what? H comma k. Now coordinate of the major vertices MV. Remember, vertical. The value of A now is now along the vertical axis, and the major axis is now along the vertical axis. C is also now along the vertical axis. So that's what has been working on your board at this point. So instead of having h plus a comma k, h plus or minus a comma k, we'll be adding the value of the center, okay, to the y part. That's why I said once you know the left part here, it's enough for you. You just be substituting. Here now we have mv to be 0 plus or minus a. So instead of, I'll just look at this one. Instead of 0, I will have the center. 0 plus h, that's h. Now, plus or minus a, I will add it to the value of the corresponding of y. That's k. That will be k plus or minus a. Yes, now, so this one is enough for you to be working with. As the only thing you need, if you are dealing with this problem, the problem that is not centered, you just need to be substituting. You get my point now exactly. So lowercase mv would be, now plus or minus b, I will add it to the value of h. So that h plus or minus b, comma, instead of 0, I will have k. Excellent. The foci now. The foci is now along the y-axis, and I'll have k to it. So that will be, now instead of 0 2, I will have h. So that will be h comma k plus or minus c. Excellent as that. Latus Rectum still remain the same, 2b squared over a. Eccentricity remain the same, c over a. And what's it called? C squared is still a squared minus b squared. And finally, the equation becomes x minus h all squared. Now remember, not a will be under h, under x element will be b squared, then plus y minus h. I would get it again, y minus k all squared divided by a squared equals to 1. That's it. So that is a summary of everything we have been discussing right from time that actually consumed more of our time. So please, I hope you find this helpful and understandable. The next thing we need to do now is to consider some practice problem and how to put everything we have learned so far into good use. Example number 1. The equation of an ellipse is 9x squared plus 16y squared equals 144. Find the coordinate of the center, the coordinate of the vertices along the major axis, coordinate of vertices along the minor axis, the coordinate of the foci, length of latus rectum, and eccentricity. So we are not scared to solve this problem because we know everything we need to be able to successfully solve the problem. So let's begin. So we have the equation given as 9x squared plus 16y squared. So 16y squared, I want to write it properly, then equals to 144. Basically, we need to express this equation in standard form. The equations I gave you so far right from start were the equation of the ellipse in standard form. You understand? So the way it is now, we need to express it as that. So basically, when you have something like this, what we need to do is that you want to get rid of the 9 and 16. So we can divide through by the product of 9 and 16. Understand? So dividing through by 9 times 16. Dividing through by 9 times 16. 9 times 16. So we can see that this 9 can cancel out. The 16 can cancel out. And 9 times 16 can actually cancel 144. That's the product of two perfect squares. Yeah, that will give us a perfect square, which is that one. Okay. So basically, we have x squared divided by 16 plus y squared divided by 9 to be equal to 1. Excellent. We have been able to successfully express it in the form that we are actually familiar with. Perfect. So when you have something like that in future, that's how you're going to do it. Okay. So now basically, remember, we said the equation is actually of the form x squared divided by. Now, before we actually interpret, let's look at the highest one. You can see 16 is the highest. So therefore, that will be the value of a. So that will be a squared plus y squared divided by 9 is b squared less than 16. That's excellent. Divided by 1. So I need the value of a. Let me take a squared set it to be equal to 16 to get the value of a. So thus a squared is 16, and it implies that a is equal to 4. By the time I take the root of both sides, the root of 16 is 4. Good. Similarly, b squared is 9, and it implies that b is equal to 3. Perfect. Please, are you following? Good. So now, the next thing is, since we have the equation, we need the coordinate of the center. Now, look at it. What would you see? Look at the equation. What would be the coordinate of the center? Since nothing else is attached to x and y, the coordinate of the center is 0, 0. C is 0, 0. As you can see, the equation actually looks similar to the equation of ellipse that is centered at the origin. Nothing is being attached to the value of x and y. Okay. If I thought something is attached to it, you will take what is attached to x, you will take it along with the sign with it. Then you opposite the sign, you alternate the sign. Let's say, okay, it's like x minus 2 now. Then your answer now along the x-axis will be plus 2. You alternate the sign. Okay. And if this one is like y plus 1, you alternate the sign and it will be minus 1. Simple as that. In case it is not centered at origin. You feel me? Exactly. So now, the coordinates of the vertices. We have answered this one. This has gone. Let me mark it in red. Let's mark it in red. So we need the coordinate of the major vertices along the major axis. Excuse me, along the major axis. Okay. Now we said MV, capital letter MV, for an ellipse. Okay, I actually have to ask one question right from start. Is this ellipse, is it horizontal in orientation or vertical? What would you say? Pause the video and answer this question. Answer it in the comments. Let me know. Excellent. I don't know if you get it anyway, but I know some of you actually get it. So it's actually horizontal because 16 is the highest value and it's actually under the x-axis. This means that the ellipse is elongated along the horizontal axis, which is along the x-axis. Thus, it's an ellipse with horizontal orientation. If that is the case, the MV, that will be equal. That will be, the first one will be plus or minus a comma 0. Okay, I already combined it, not the first one and second one combined. Okay, that will be equal to a bracket. What's the value of a? That's 4 plus or minus 4 comma 0. I got that. Simple. Consider perfect. Now, Coordinate of the minor vertices, lowercase mv, that will be 0, plus or minus b. And that will be 0, plus or minus 3. This is b. Excellent. Next one, coordinate of foci is an ellipse with horizontal orientation. The value of c will be along the x-axis. Coordinate of foci will be plus or minus c, 0. So we need c. C squared is a squared minus b squared. This is what I'm saying. At this point, we need this equation. Am I communicating? We need this equation. C squared is 4 squared minus 3 squared. That's 16 minus 9. C squared equals 16 minus 9. That's 7. C squared is 7. Taking the root of both sides, c is the root of 7. Thus, we have the value of c. So I'm putting that somewhere around there. C is equal to 7. Am I communicating? Thus, we have it to be plus or minus root 7, 0. Perfect. Length of latus rectum, LR, is equal to 2b squared over a. That's 2 times b squared is 9 divided by a is 4. And that's 18 by 9. As the product of 9 and 2 is 18. And in fact, I got 9 instead of 4. And if we reduce this, that should be 9 by 2, which is 4.5. But I leave it as 9.2. Eccentricity, lowercase e, is equal to c by a. C is root 7, and the value of a is 4. So you can put this into your calculator and get your value in decimal. And that gives us the solution to example number 1. How you grab it? Now let's consider a situation where we have an ellipse that is not centered on the origin, and then compare the difference. So, example number 2. Find the coordinate of the center, the major vertices, the minor vertices, and the foci of the following ellipse. Thus, find the length of the latus rectum and the eccentricity. So now, the equation is given as x minus 3 all squared divided by 16 plus y plus 2 all squared divided by 25 plus 1. To solve, before you solve any problem, I would advise that you should first know your ellipse. Are we having an ellipse with a vertical orientation or an ellipse with a horizontal orientation? What's your answer? Well, to know that, let's look at the axis that has the highest value under it. This has 16 and this has 5. So this has 25. Since y has the highest value, that means we are having an ellipse with a vertical orientation. This means, the value of c, the value of a will be along the y path. Now I'm getting perfect. So now to get the coordinate of the center, c would be, like I said, take the value along the x path that is attached to x, value attached to y, alternate their signs, put it inside, and that's all. So that will be 3, minus 2. Another we can do, if you actually want to be simple, okay, you can just set x minus 3 to be 0 and y plus 2 to be 0. It means x will be equal to 3 and y will be equal to minus 2. So these are the center of the circle. Because I said circle, ellipse. So now, this has gone. We have the center already. Now we need the major vertices. Capital letter MV. That will be, remember, it's not at center. It's not at center. So it will not be 0, plus or minus a also. It should be h, the value of a, or let it be k, first, k plus or minus a. Are we here? This is how it's expected to be expressed. So we need the value of a. Remember, a will be the largest. So we take a squared to be equal to 25, and this implies that A will be equal to 5. Then B squared will also be 16, and this also implies that B is equal to 4. So basically, since I have the value of K to be minus 2 and H to be 3, remember, that will be H comma K 2 respectively. And that will be equal to the value of H is 3, the value of K is minus 2. So I'm doing minus 2 plus or minus 4. So I need to express this and simplify. So MV, I need it in capital letter. The major vertices would be, the first one will be 3, comma, minus 2 plus 4, that's plus 2. And 3, comma, minus 2 minus 4, that's minus 6. So this is the coordinate of the major vertices. Now, for the minor vertices, the work is MV. Remember, that will be in relation to the value of B. Now, B will be along the x-axis. So we have H plus or minus B, comma K. Am I communicating? Perfect. So that will be equal to H is what? H is 3. So we have 3 plus or minus. The value of B is what? B is 4. With them. Excuse me. I made a mistake here. Instead of 4, it's supposed to be 5. This is supposed to be 2 plus or minus 5. That's the value of A. I instead put the value of P. Okay? But and this will not be 2. And this will not be minus 6. So minus 2 plus 5 is 3. That should be 3. And this should be minus 2 minus 5 is minus 7. Excellent. So that will be 3 plus or minus the value of B is 4. So now we can split that and have lowercase mv, the minor vertices, to be 3 plus or minus again. I haven't put the value of K, which is 2. So that will be minus 2. Okay, plus or minus 4. Then comma, the value of K is 1, minus 2. Okay, I hope you're not lost yet. So this is H plus or minus B. So B is 4. Then we have it right here. Then the minus 2 is this one, the value of K. Am I communicating? Perfect. So that will be 3 plus 4. That should be 7. So D should be 7. When we are trying to expand everything, that will be 7, comma 2. And 3 minus 4, that will be minus 1, comma minus 2. So this is the coordinate of the minor vertices as well. So that is that. On to the foci. Here's how, if you're following, that's how you can easily solve problems on ellipses. For the foci, since it's a vertical orientation ellipse, the foci will have its value along the y-axis. So, and also, since it's not centered at the origin, the value along the x-axis will not be 0. Instead, it will be h, comma, the value of k plus or minus c. Perfect. So we need the value of c actually. Okay. Now, since c squared is equal to a squared minus b squared, c squared would be equal to a squared is 25, b squared is 16. C squared will be, the difference of these two is 9, and taking the root of both sides, the root of 9 is 3. Okay, perfect. So it means the foci, its coordinate would be h is 3. This is the value of h. That's 3. So we have 3, comma, the value of k is minus 2. So we have minus 2 plus or minus 3. Are we together? Perfect. Now for those who might be like, the root is plus or minus 3, you are still doing the same thing. You understand? When you need them, you put it. Okay? It's expected to be put and it will be there. It's actually in the formulas and the way we put all these things. So using positive like this is still perfect enough. You feel me? So we are just trying to consider positive values. Because some of you might be wondering, yeah, I have people who might be like, why am I using plus 3 when root of 3, root of 9 is plus or minus 3? Well, the case is still perfect. Understand? Just considering positive values. So now, Let's simplify. Let's expand this. So that will be 3, comma, plus 2, minus 2 plus 3. That's plus 1, 3, comma 1, and 3, comma, minus 2 minus 3 minus 5. So that's the coordinate of the foci. That's the coordinate of the foci. Perfect. And that's the solution to the center, major vertices, minor vertices, foci. Now we need the Latus Rectum. So LR would be equal to 2b squared over a. That's 2 times 16 divided by 5. That will be 32 over 5. In how many different ways can 5 go in? 32. 6 remains at 2. That will be 6 whole number 2 over 5. So that's the Latus Rectum. Eccentricity E is equal to C over A. C is 3 and A is 5. And that is the eccentricity. And that's also the solution to example number 2. And a simple as that. On to example number 3. Feel free to pause the video and figure this out yourself. Find the equation of the ellipse whose vertices are 3, 4 and 13, 4 and whose eccentricity is 1 over 5. So basically now, these are word problems involving ellipse. You won't have the equation, but instead you'll be required to find it. So what do you do? Now if you have the vertices and you are required to find the equation of the ellipse, then the first thing I will suggest you consider doing is finding the center of the ellipse. Because remember, the equation of the ellipse would either be x squared over a squared plus y squared over b squared equals to 1. Or it should be the one that is not centered at origin, x minus h all squared divided by a squared plus y minus b, b, y minus k all squared divided by b squared equals to 1. So if you rather be any of this, but still remember, if it's not a horizontal orientation, if it is vertically orientated, the value of a and b to be changed. So you need these two things. You need to know the ellipse you are dealing with. 1. At the same time, you need the center of the ellipse. Either it is the coordinate of the vertices they give you or the coordinate of the foci. This method I want to show you now will definitely works. And that's the best thing I would suggest to consider putting into account first. So first, let's find the center. After we have the center, let's know about the ellipse. To get the ellipse, look at these two coordinates given to us. We can use them to get the center of the ellipse. We are given the vertices, but they didn't tell us maybe it is major vertices or the minor. If they didn't specify, consider it as a major, because that is the most often given. Am I communicating? That's the most often given. Only if they specify that it is minor, that's when you consider that coordinate as minor. And in fact, even if it is minor vertices it gives us, this will still help us. It will still help us to get the center of the circle. So why am I mentioning the circle of the ellipse? Are we there? Perfect. So we'll actually learn coordinate geometry. When we have two coordinates, we can determine the coordinate of the midpoint of the line segment joining the two coordinates. Now remember, let me show you an actual illustration of what I'm saying ellipses. Is that an ellipse? Let's work with that. This is an ellipse, for instance. We said if it is horizontal in nature, this point and this point, we say they are the coordinates of the major vertices. Okay? Now, the line that joins these 2 points, if we find it's the coordinates of the midpoint of the line that joins these two midpoints, if it is somewhere around there, doesn't that coordinate correspond to the center, the coordinate of the center of the ellipse? It does. You feel me now? Exactly. So that's what we are trying to do. We are trying to find the coordinates of the midpoint of the line segment joining the two coordinates we have here. Because that coordinate of the midpoint of the line segment joining the 2 points will correspond to the midpoint, or will correspond to the coordinate of the center of the ellipse. Am I communicating? So that's what we are trying to do. So basically now, to get the coordinates of the midpoint, what do? The formula is such that the coordinate of the midpoint, x, y, is equal to x 1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. So x1 is the first one, y1 is second one, x2 is second one, y2 is second one, third, fourth, to see make sense. So x1 is 3, x2 is 13, y1 is 4, y2 is 4. 13 plus 3 is 16 over 2. 4 plus 4 is 8 over 2. So we have 8,4. So this is the center of the ellipse. Am I communicating? Perfect. Now that we have the center of the ellipse, are we required to find the center of the ellipse? We are not, but we have given them bonus. We find the center of the ellipse for them. So C is 8,4. That's okay. Now, that one that we have C, we clearly know that the ellipse is not centered at the origin. It means this can never be an equation of the ellipse. So it will be this one. Now, will it be this one? Will it be this one? Or it should be this one? X minus h all squared divided by b squared plus y minus k all squared divided by b a squared. So it must be one of these two. To now know which is going to be equals to 1, I have which is equals to 1, equals to 1. So now know which is going to be next sense. You must know your ellipse. And the question is, how do you know your ellipse? I even expect you to know how you can know your ellipse, because it's part of, when I was disclosing the concept, I actually made mention of it, that if you are given the vertices of the ellipse, you can use it to know the type of ellipse you have. Yeah, let me call it for you. You pay attention to the vertices value. If you look at the coordinates of the vertices, which axis tends to be having the highest value? Look at it. 3,4. Though 4 is more than 3. But when it comes to the other one, we have 13,4. Far away. X-axis is having more value. That tells you that it's a horizontal orientation ellipse. Am I communicating? No matter what, that is enough for you. One of those coordinates will have the highest. You understand? If it's y part that's having the highest, it means it's a vertical orientation. You get my point now? Even without carving your ellipse, you can use this to know what type of ellipse you are dealing with. So this ellipse is actually horizontal in nature. Thus, this is the best one to use. So the largest value will be under x. Are we there? Now that we have the center, the equation will be x. Now, if you have the center and you want to put it in the equation, you have to alternate the sign. Remember, if you have the equation, you want to put it as a coordinate center, you alternate the sign. It is vice versa. So it is 8 before. When it's going right in the equation, it becomes minus 8. So minus 8 all squared divided by a squared. We get the value of 8 on 1. A squared plus y minus k is what? 4 all squared divided by b squared equals to 1. Good. We are on the safer side now. We are moving forward. The goal now is to get the value of a and b respectively. So what do we do? Well, we are given eccentricity. E, lowercase e, let me have that in black, is equal to c over a. How do we get c? That is the question. What do we do to get the value of c? So what do you think? Since we have the coordinates of the vertices, we can actually get that length. You know, what we did here was that we actually got the coordinates of the midpoint of the line segment joining the 2 points. What if we want to determine the magnitude of that line? Let me show you what I'm trying to explain. Makes sense. You know, if this is the ellipse now, we said from here to here, this is the first point. Let's say, okay, there's 3,4. While the other one, we said that's 13,4. Good. So now, right now, we said, okay, we use the midpoint formula. We use that to get this one. And we got that as 8,4. Remember, we said from the center of the ellipse to one end of the ellipse along the major axis is the value of a. And same thing applies, negative a for the left hand side. Can we have this point, we have this one. Can we use the distance formula to get the value of A? Yes, we can, because we have the two coordinates. You understand? And if you don't want to do that, you can get the distance from here to here divided by 2. You must still get the same value of A. You get me now? Because initially, my own mind is that I want to do this and this. I will get the length, then divided by 2. But upon showing the visual illustration now, I realize that we can actually use this and this and get the value of A. We will still get the same answer. And that's what I'm going to use. I don't want to divide by 2. Okay? If you want, you can divide it by 2. So now basically, what does this distance formula says that? It says, okay, the magnitude of the line joining 2 points, let's say the value of A, magnitude, is equal to the square root of the square of the difference between the two corresponding coordinates, x2 minus x1 all squared plus y2 minus y1 all squared. Clear that with me? Okay. So let's put the values. Square root of x2, this can be x1, x2, this can be y1, I made a mistake. x1, y1, x2, y2. So that's going to be x2 is 13 minus 8 all squared, then plus y2 is 4 minus 4 all squared. So that's going to be 13 minus 8, that's 5. Yeah, that's 5. And it means the value of A will be equal to the square root of 5 squared. 4 minus 4 is 0, 0 squared is 0 plus that's gone. The root of 5 squared is 5. So 5 squared is 25, the root of 25 is 5. So that's equal to 5. The value of A is 5. Now, E is equal to C over A. That's very good. We can now get C. Since E is given as 1 over 5, it means 1 over 5 is equal to C over A is what? 5. Now, upon cross multiplying, you can see that C will be equal to 1. How? If I cross multiply, I have 5 times 1, which is 5, to be equal to 5C. Dividing 2 by 5, C will become 1. I have that. Am I communicating? Okay. Now, let's get the value of B using C squared equal to A squared minus B squared. So now this can go. Now I said C squared equal to A squared minus B squared. C squared will be 1 squared. A squared will be 25 minus B squared is what we are looking for. We bring it this, we have B squared equals to 25 minus what would that be? 25 minus 1. And B squared will be equal to 24. Perfect. Now we have the value of A and B respectively. We can now get our equation in the very best form. Thus, the equation of the ellipse will now be, now instead of A squared minus B squared, I still want to use this one. Now just get rid of the two of them and put the actual answer. So A squared is 25. So we have 25 plus B squared is 24. And this is the equation of the ellipse. That has its eccentricity to be 1 over 5 and the coordinates of the major vertices to be 3,4 and 13,4. So that's it, guys. On to example number 4. By now, I believe you should have been developing your understanding in the topic. So let me try to shift this down a little bit so you can see it properly. So with this, yes, I'm certain that whatever problem you'll be coming across, you should be able to handle them. Let's say an ellipse has 2 of its vertices at the points -4, 3 and 8, 3. If one of its foci is at point 6, 3, find its equation. I expect you to be able to do this problem. The only thing is that they didn't give us the eccentricity, they give us the foci. This one is even more simpler than the previous one. Or I should allow you to use that exercise. Use that exercise. Yes, because it's even simpler than this one. Because I already know the eccentricity, you are not using that one. Just do it. Let me know your solution in the comment section below. Okay? Feel free to share your solution with me via the comment section below. Understand? It is the foci you have. They already give you the value of C. You do what you do, you get A. You get B, you get your answer. So I've given you bonus. Let's move to the fifth one. So on to the fifth one. Let me adjust that to think so you can see properly. Okay. Find the equation of an ellipse whose foci are minus 8,0, 8,0, and whose eccentricity is 3 or 4. Well, this one is quite different from the ones we have been dealing with, so I will actually make an attempt with this one. So we have the foci and we have the eccentricity. We need the equation of the ellipse. So first, the equation can either be x squared over a squared plus y squared over b squared equals to 1, or it should be x minus h all squared divided by a squared plus y minus k all squared divided by b squared equals to 1, or the values of a and b should be flipped. So it depends on the orientation. So we need to know the orientation of the ellipse. But before we do that, we actually need the center of the ellipse. We must know if the ellipse is centered at origin or not, for which to be able to know if it's going to be of this one or of this one. Like I said, if this coordinate of the foci that is given to you, you can use to get the center. If this coordinate of the major vertices that's given to you, you can use to get center. If it's for the minor vertices, you can use to get center. So f is minus 8, 0, and 8, 0. So we have x1, y1, x2, y2. So the midpoint, x, y, will be equals to x2 plus x1 divided by 2, y2 plus y1 divided by 2. Are we there? Perfect. So right now, x2 is simply 8 plus x1 is minus 8 divided by 2, y2 is 0, y1 is 0 divided by 2. So 8 plus minus 8 is 8 minus 8 divided by 2, 0 plus 0 divided by 2. That's 0 over 2, which is 0, 0. Excellent. The ellipse is set at the origin. These go. These we need you. So that's what we are doing actually. It will either be this or the value of a and b should change. So this can go at this point. We don't need it anymore. Okay, now that we know that it will either be this or the value of a and b should change, now we need the orientation to know which exactly is going to be. This it will either be x squared over a squared plus y squared over b squared equals to 1, or it should be x squared over b squared plus y squared over a squared equals to 1. So it's either be any of these two. So let's confirm. We need the orientation. To know the orientation, we must know the axis that we have the foci. You know, horizontal axis. The foci will be at the horizontal, it will be at the x-axis. The major axis, we have its largest values along the x-axis. Now communicating. And what else can you use? The equation. You understand? But now we don't have the equation. So you can either use the foci or you should use the major vertices. But now also we don't have the major vertices. So we can only use the foci. And the deal is that the foci will be on that axis. Now, where is the foci? It's along the x value. You can see it's along the x is what's called an x coordinate. It has the largest value 8 along the x coordinate. For the y values, it has 0, which is very small compared to 8. So therefore, it is an horizontal orientation. So therefore, this is the best one. Our equation is of the form x squared over a squared plus y squared over b squared equals to 1. Am I communicating? Perfect. So we need the value of a and b respectively. We have c already, you understand? And we have the eccentricity. Because remember, c is with respect to the foci. And since it's the center at the origin, we have the center, okay, I don't know the coordinate center. Center is 0, 0. Remember the foci, f, is, since it is horizontal, it will be h plus or minus c. No. Yes, that way, 0. Or the value of k. Let it be k. But the two of them are 0, 0. H is 0, k is 0. You understand? That's why we have it as minus 8, 0 and 8, 0. 8 is equal to the value of c. Yeah, because h and k are 0, 0. That's why we have the foci to be plus or minus 8, 0. That's why you have the first one to be minus 8, 0, and the second one is 8, 0. So thus the value of c is equal to 8. You understand? Now e is c over a. What was it called? E is what? 3 over 4. according to the problem, is it C is 8, A is what we are looking for. Upon cross multiplying, we have 3A to be 4 times 8, that's 32. We divide this by 3, and the value of A will be equal to 32 over 3. Okay, A will be 32 over 3. So now basically, we need to square it. Now we squared it, we'll have 32 squared. I need to use my calculator for that. So I shall know that 3 squared will be 9. Not 32 squared. Let me use my calculator for that. Okay. Okay, for 32 squared, I got 1024. Okay, as I said. So basically now we need the value of B squared. Now we said that C squared is equal to A squared minus B squared. Now if we solve for B squared will be equal to A squared minus C squared. C is 3 over 4, and that will be A squared is 1024 divided by 9 minus. If we square 3 over 4, that will be 9 over 16. We need to find the LCM. This can go. Hope you are following, please. Now to find LCM of 9 and 16, it should be 144. Yeah, we'll multiply them. So 9, 144 is 16. 16 times 1024. 16 times 1024. 16,384. The minus 16 144 is 9. 9 times 9 is 81. So 16,384 minus 9 is 16,375 over 144. So that's B squared. We don't need to take the square root because we are just going to plug it right into the equation. So final answer to that equation, that becomes x squared divided by A squared is 1024 divided by 9, and plus y squared divided by B squared is 16,375 divided by 144 equals 1. Now we can't leave like this. Let the 9 come all the way upward and 144 to come all the way upward by using the method of keep, change, and flip. So we have 9x squared divided by 1024 plus 144 y squared divided by 16375 equals 1. And that is the equation of the ellipse. Guys, I have to pause video and look at the solution very well. Yeah, I realized that when I divide 9 divide 1024 by 9. Okay, I got 0.008. 0.008. Okay. Yeah. Like reduction of 1024. 1024 divided by 9. I got 113.77. And that's a square. 113.77. Now when I now do 16,375 divided by 144, I still get 113.715. Meanwhile, the value of A has to be more than the value of B. So I was wondering where the mistake is. Okay, so I take my time and look at the solution, and I realized that instead of using the value of C, I use the value of E. Okay, that's a messed up. Okay, that's a messed up. If you actually observe that right from when we were solving it, let me know in the comment section below if you observed that. Okay, but if you didn't, let me know. Likewise, let me know. So there was a mistake there actually. So I supposed to use the value of C, and I used E. C is 8, so we're supposed to use 8. Okay, supposed to use 8. So please, very, very sensitive while solving problems. It's very, very important to be very, very careful. Nobody ever made mistake actually. So I think this is actually out of the box then, and this is out of the box. This is also out of the box. and that's still there. Okay, so C is 88. It's supposed to be 8 squared, and that should be 1024 divided by 9 minus 8 squared is 64. 64 divided by 1. So if the LCM is 9, we should have 1024 minus 9 times 64. 9 times 64, that's 576. And I squeeze it there, 576. And basically I can take the difference. 1024 minus 576. So I got 448 divided by 9. Okay, perfect. So basically now, that's the value of b squared. Excellent. That's the value of b squared. I think it makes sense now. This makes sense now, yes. So now we can plug in. So we should have x squared divided by a squared is 1024 divided by 9. So 1024 divided by 9. Then we have plus b and y squared divided by b squared is 448 divided by 9 equals to 1. Now if you use the concept of keeping and flip, you should have 9x squared divided by 1024 plus y squared, 9y squared divided by 448 equals to 1. So this is our final answer. So now it makes sense now. The value of a is now more than the value of b. Okay. So I hope you find this helpful and understandable. I want to believe you benefit from this video tutorial. Thanks for watching. See you in the next video. Bye for now. Also, if you want me to be creating much more longer videos like this in the future, feel free to give a suggestion via the comment section below. And don't forget the assignment I gave, the exercise I gave. I'll be expecting your solutions. Thanks for watching once again. Bye for now.